Hi, my name is Karsten. I'm a Principal Solutions Architect at Amazon Web Services. In this video, I cover how to test your application's performance on AWS Graviton. This is the first of 3 short videos on this topic. My assumption is that you're watching this video because you want to test your application's performance on Graviton, and you're trying to figure out the how. This will serve as an input for a decision such as to upgrade or migrate to a next generation instance type. And then depending on the answer, how you can secure the capacity in order to make the switch. So I totally understand that you're not taking this decision lightly, with potentially large amounts of budget at stake. What I will teach you in the next 3 videos is what you should consider when making the switch. Next, how you can take the guesswork out of your performance tests. And then how you can generalize results beyond a single snapshot captured by your test environment. But first, I want to set some context. Imagine that your manager asks you for an opinion whether a migration to Graviton will improve application performance and save cost. As application owner or developer, you know there are many ways in which you could answer your manager's question. You could, for example, refactor code to improve performance and maintainability. You could finally upgrade to that latest version of the Java runtime. You could tune operating system parameters to improve performance, efficiency, or responsiveness of the system. Or you could switch your storage layer to a next generation Nitro SSD. What I will show you as part of this video is how you can narrow down choice, how you can focus on instance selection, and then gather data to provide a recommendation back to your team about whether an instance upgrade or migration delivers the outcomes you all anticipate. Your first step is to define a clear baseline for acceptable application performance. In my example, the purple line represents acceptable application latency, something that I measure as the time between a client's request and then when the server responds. In a traditional x86 system, hardware multithreading works by using idle resources to increase throughput. In my example, the blue line represents typical application performance in a multi-threaded system under increasing load. CPU effectiveness diminishes as load increases, and those processor resources are no longer readily available. In other terms, contention in the system increases. Eventually, you reach a point where your system becomes unresponsive, and you need to scale out in order to continue serving application traffic. By contrast, in Graviton, every thread maps to a single physical core, and there is no hardware multithreading. In my example, the orange line represents typical application performance in a Graviton system under increasing load. The system continues to process requests with acceptable latency long after we had to scale out in our previous example. Again, eventually we reach the same point at which we need to scale out, but this point will be later and more gradual compared to our previous example. This means that your mental models of when to scale out and how much headroom you have to leave on the system will have to change. In conclusion, I recommend that you avoid the tendency to lift and shift assumptions from one system architecture to another. Make sure that you fully load the system when testing application performance up to the point of breaking latency. One way of doing so is to gradually ramp load until you see latency and error rates spike. Let data drive your instance selection, sizing, and scale-out decisions, not assumptions. With that, we can now move on to discuss the how of data collection.